completing my square. So if you remember, completing my square is when we have to write it in a form, something like x plus a squared plus b. That's what it tends to say in the exam. For this kind of question, you'll very rarely see complete the square written down in an exam paper. You'll see something like that instead. Now you'll remember this from Nat 5, and in Nat 5 it always started with an x squared term. So never a 3x squared, never a 4x squared, never a minus x squared. So as part of this video we'll learn to tackle having things other than a simple x squared at the start. Okay, but first of all, a quick recap of what we should do with this. Well, we want to look at those first two terms, open up a bracket, the x squared becomes an x, the 8x, we drop the power, just like we did here, x squared becomes x, we drop the power here, and in this case, the x just disappears, it becomes a number term, we half 8 to get 4, and it stays as a minus. Now we put a square here, plus 11, it's still happily just sat there, we haven't touched that yet. Now if we were to expand out x minus 4 squared, we would get x squared, we would get minus 8x once we'd done FOIL and simplified, we'd get an extra 4 squared, we get an extra 16. So what we have to do is, we can't just replace this with this because those two things are not equal. This contains an extra 16, an extra 4 squared, so we have to take away that 4 squared, that's 16. Okay, so that's what we do. Square the 4 and take it away. That gives us x minus 4 squared plus 11, take away 16, minus 5. So if you need more practice at that, then I do have a video in the comment section that I'll link to from a Nat 5 course, practicing some more of this. But just before I move on to the more difficult terms here, I just want a quick reminder of what we can get from this. Well, we can think of this in one of two ways. We could imagine writing it as a y equals x squared minus 8x plus 11. Now what could we get from this if this was y equals? In other words, if we're thinking about a graph. Well, if we're thinking about a graph, then this leads us to the turning point. And the turning point would be to where we flip this here. So instead of minus 4 for the x coordinate, we get 4. And for the y coordinate, we just take it as it is, minus 5. So that gives us the turning point on a graph. And what else might we want to know? Well, is it a maximum or a minimum? This is a quadratic, so it's going to be a parabola. So it's either going to be a U shape or an N shape. And if you remember, positive x squared term, positive means smiley face. It's going to be a U shape. So this is going to be the kind of the bottom of that U shape. In other words, it's going to be a minimum. Okay, bottom of a valley. So we could draw this by finding 4 minus 5. And it's going to be a U shape. Okay, it's a second interpretation that's going to be really useful for this. So instead of thinking of it as a graph, you could also think of it as a function. So let's write fx to get us thinking about that. So for a function, we put in an x value. So we could put in an x value of 1 into here. 1 squared is 1. Take away 8 ones, that's minus 7, plus 11 is 4. So we could put in an x value of 1, and we could get out a function value, the size of a function, as, what did I just say? 4. Okay, or we could put in an x value of 10. Okay, and let's see what function value we get out. So the input, the x value is 10. We'd get 10 squared is 100. Take away 8, that's 20. Plus 11 is 31. So we could put in 10 for x and get a function value, as 31. And it's kind of similar to the graph. So where might we want to go from that? Well, what if I wanted to know what the highest possible value this function could get to? What's the biggest possible number I could get out by trying all different kind of x values going in there? And if we think about the graph, actually, we'll find that there is no maximum. So this function can go as big as it wants to. We could just keep putting different x values in, and we could get really huge answers. There is no biggest function value. But is there a lowest function value? Well, there is. And again, if we think about the graph here, we can see that there is a lowest value to this function. And the smallest possible value for this function we could get, so I'm thinking about y coordinate here, the smallest value of this function is minus 5. So this fx has got a min value of minus 5. In other words, no matter what x value I tried in here, I'm never going to get an answer smaller than minus 5 for the output here when I put x in. Now, what x value would give me that value of minus 5? Well, again, I can take that from here. And that happens when I put in an x value of 4. So what I'm going to do, and we can take that straight from here, the minimum function of a value is, minimum is -5. That happens when x is 4, when you put 4 in. So for each of these next few examples, we're going to practice the mechanics of completing the square for things other than just an x squared, like a 2x squared or a 3x squared. And each one we're going to write down the minimum, and we are going to write down the, in terms of function, what's the lowest a function can go to. Okay, so a couple of examples here when the x squared term is bigger than 1. So for example, 2x squared, 3x squared, or 4x squared here. So you might see this written slightly differently because this time we're actually going to end up with something in front of a bracket. So it might write it something like this: ax plus b squared plus c. You don't really need to worry too much about those letters. In general, the main thing is that you recognise this is still, it's asking you to complete the square. Okay, so first thing is, basically we don't want to do it when there's, when it's not just an x squared term. We want it to just be x squared, not 2x squared, not 4x squared. So the first thing we're going to do is we're going to factorise only the first 2 terms here. So I'm going to take a common factor of 4 so that I can write 4 brackets x squared plus 4 times 6x plus 50. So now inside a bracket, it starts with an x squared and not a 4x squared. Now, at this stage, I have not dropped the power to make it an x. I've not got rid of this x here, and I've not halved it. All I've done is taken a common factor. I think it's really important that we don't try and do anything else apart from take a common factor in the first stage. So now what I'm going to do once I've done that is now I can do the usual x squared becomes x plus we're going to get rid of an x and the 6 becomes a 3. So now we half it. Now what would we normally take away at this point? Well, we'd normally square the 3 to get 9 and we take it away. However, before we do that, we do square the 3, we do get 9, but before we take it away, I want to multiply it by 4, the number in front of the bracket. So 3 squared is 9, times by 4 is 36, so I'm actually going to take away 36 instead of 9. So that gives me 4 brackets x plus 3 squared plus 14. Okay, and that's it done. So let's go on to this one here, and let's be really careful with this one. So what's the first thing I'm going to do? Well, I'm just going to take a common factor of 2. Now I'm not going to try and change this into just an x. I'm not going to try and half it here. And this is where some people get a little bit tripped up, because we look at this and say, okay, I just halved it. And yes, you did half 16 to make 8, but what we really did here was took a common factor of 2. Okay, so just like the first step was a common factor step, the first step here was a common factor step. Okay, we've still got to do our normal dropping the power halving it step. Okay, so I don't like to think of that as halving it, I like to think of that as just taking out a common factor of 2, and now I'm going to think of halving it. X squared becomes x, take away 4 squared, take away 9. Am I going to take away 16? 4 squared is 16, but I need to multiply it by 2. So 4 squared is 16 times 2 is 32. And that's what I'm going to take away. Square it, multiply it, and then take it away. Okay, so that gives me 2 brackets x minus 4 squared, take away 41. Now, a final thing I want to say here is, can we still get our turning points? Well, first of all, both of these are positive squared terms, so both these are u-shapes. So both of these are going to have the bottom of a valley and minimum turning point. Now, what is the minimum turning point? Does it get more complicated because of this 4 and this 2? No, it doesn't at all, actually. We're still going to take the term here, but we're going to reverse it. Okay, it becomes minus 3, and we're still going to take the term here. So we didn't even need to pay attention to our 4. And the same here. What's our minimum turning point? Well, we reverse it, we get 4, and we take this one as it is, and there we get the minimum. Okay, and a wee word on what I said last time. The other way of thinking about this, apart from thinking about the graph, turning point, is to think about what's the lowest, the minimum, that these functions could ever go to. So if I keep putting x values in, what's the smallest this would ever be? And it turns out that the smallest it would ever be, like the y value, is 14. And I would find that smallest value when x is minus 3. And the same here, what's the lowest this function could ever be? The lowest it would ever get to is minus 41. and I would find that by putting x equals 4 in there, and I could test that. I could put 4 in here, try it out, and I would get minus 41. Okay, completing my square, the final bit with a minus sign in here in front of the x squared, so it's a negative x squared term. So I'll come to this in a second. What would we say to get you to do this step? Well, let's assume we know that we've been asked to complete the square. Here's what we do. Well, it's a very similar process to last time where we took a common factor, only this time we're going to take a common factor of minus 1. But what it might be easy to see is we're actually just going to take a common factor of kind of a minus. That's what it looks like. Because remember, we don't write minus 1 as a common factor, we just write negative. So we're kind of taking a negative sign out of here, so that would be inside of a bracket x squared, which is what I want, just x squared. Now minus something to give me positive 6x. So it would need to be a 6x there. Because otherwise, well, that was going to give me minus times a minus is plus 6x. So really carefully check the second term there. Does that give you what we wanted? Minus times a minus is positive. Okay, and if you put something in, read it back, and it doesn't read right, then you would just need to flip the sign until it does. Now again, have I halved it? Have I dropped any powers? No, that was purely a common factor step. So now we're going to do that usual completing the square step. X squared becomes x, take away, drop the x, make it a 3 squared there, don't forget that, minus 4. Normally we would square 3 is 9, and we would take it away. Two ways of thinking about this. Like last time, before we take away 9, we're going to times it by what's outside the bracket, which is a negative. So that means we're going to take away minus 9. Well, that's just adding 9. Now, the other way of thinking about that is that you basically, with completing a square, you are always going to take away unless you've got a minus in front of a bracket. So sometimes that's easy to think of. Always take away unless you've got a minus, in which case you add. So that gives us minus x minus 3 squared plus 5. Okay, and that's fine. That's a perfectly good answer. Some people don't like leading with a minus sign, so some people might write this as, well, why don't we put 5 first instead? 5 minus x minus 3 squared. It's exactly the same thing. You could choose, but the reason I mentioned that is that the exam question sometimes might say, write it in the form a minus x minus b squared, okay, or something of that form, and they're actually just also asking you to complete the square. Okay, it's just written in a slightly different way. So let's have a go at this one. First of all, I don't like this because it is not in the right order, so I'm going to rearrange it. And I'm going to do it exactly as before. Common factor of a minus there. Now let's have a look at this. Let's check it back. Minus times x squared is minus x squared. Good, so that bit's fine. Minus times minus 2x is plus 2x, but I don't want plus 2x. So I've made a mistake here, obviously. So let's try making it a plus instead and see if that works. Minus times positive 2x, good, that's minus 2x. So there we go, I've fixed that there. And now we can go on to our next step. Okay, so where did that 1 come from? Well, 1 squared is 1. But what should I be doing? It's a minus in front, so I should be adding that 1. So that gives me an answer of minus x plus 1 squared plus 6. And again, I could choose to write it in that way, or I could just leave it as this way. Complete my square. Final thing to mention of that is, again, the idea of the minimum turning point. Well, hang on a second, these are minus x squared functions. So these are actually going to make an N shape. So they're not going to have a bottom of a valley, a minimum, they're going to have a kind of top of a hill, a maximum. So what are those maximums? Well, our question again is, does it get more complicated? I'm going to ignore this line for this, I'm going to look here. Okay, does it get more complicated because of a minus sign? Well, actually no, the main thing is to remember it's a maximum. Apart from that, we flip this to get 3, and we keep that the same, and we get a maximum of 3, 5. And the same idea here, we flip this to get a maximum. We get minus 1 here, and 6 here. And what does it mean this time? Well, this kind of function, it turns out that if you choose different x values, you're never going to find a lowest value because, you know, it will just keep getting smaller and smaller. However, this function does have a maximum. So if you try different x values, the maximum value of this function is ever going to get to is 5 as an output. Okay, you put that x values in, the biggest number you're ever going to get out is 5, and you will find that when x equals 3. Same here, the biggest value you're ever going to get out of this is 6, and that is when you put x in as -1.